Welcome to Geomodeling while Geosteering with smartSTRAT and Remote Geosteering with WebSteering. In today's agenda, we'll start with Geomodeling while Geosteering with smartSTRAT. First, we'll set up smartSTRAT. Next, I'll explain how the horizontal and vertical panels work together to give you the best accuracy in your geosteering efforts. Then we'll geosteer using multiple type logs. Then, using smartSTRAT, we're going to update the geosurface model, and then send the interwall points that we generate with the geosteering to GVERSE Geophys to update the velocity model for the seismic backdrop. Then we'll shift gears and do remote geosteering with WebSteering. I'll show you how to set up WebSteering, followed by geosteering using the WebSteering application. Then we will export the steered well to smartSTRAT, and then update the geosurface model in smartSTRAT. And now for the demonstration. This is an area in North Texas in the Barnett. This is a horizontal well field, and we're going to be focusing in on one well right here to use for our demonstration for geosteering. So let's zoom into this section of the area. And let's pick this well here. Now if I right click and I go to create smartSTRAT using vertical section here, it will automatically set it up for you by looking at the landing point XY and the TD XY and then laying out the line of section along the azimuth of the horizontal well. So we always want to work full screen. Now on the smartSTRAT options, this is the well, and then the active surface or the target formation we want to pick. This is the surface we're going to be using for steering. So we're going to pick the upper Barnett surface. And by the way, you can have more than one model, so you can have multiple what-ifs. So if you want to do more than one, steer one, then switch to the other one and steer it. It gives you a chance to look at different ways of steering using different type logs and seeing which gives you the best fit. Now another thing I'm going to do first is set up the scale for the gamma ray from 0 to 200 API units. And then click on the tie points tab. Now this horizontal panel right here goes along the entire length of the well. The red curve here is the LWD, or logging while drilling well, in this case the gamma ray, and it matches the gamma ray that I'm showing on the color-filled well log. The blue curve is what we call the predicted curve, and it takes the type log. Now in this case, we call this the local type log because when we designed this, we figured the closest vertical well to you, at least in the near horizontal section of the well, is the TVD of the well itself. So we're taking the TVD down to the landing point and creating what we call a local type log here. So by taking this type log and looking at initial depth of 0, this is what the response of the LWD should be. And obviously it's not, so therefore we know the dip is not 0. So the steered surface is the upper Barnett, and it's picked in this well, and this magenta line represents the dip surface. So what we'll do is we'll start with the dip slider and start adjusting the dip, and as we do, it updates the predicted curve, and we'll adjust that until it matches the LWD right here, and it matches at about 0.559 degrees of dip. So at this point I'll right click and I'll add a tie point, and we'll continue the process. Something about like that. Right click, add a tie point. Now the way I like to geosteer, I like to look for patterns. I call this a smile pattern, this a frown pattern, a smile pattern, a frown pattern. These are potential stratigraphic traversals. So when I divide up my segments, I like to say, well, this may be going up or down stratigraphically, or down or up. I don't really know, but by segmenting it with another tie point, which I call a trial tie point, I can segment this section of the LWD So I'm only going to be dealing with either a stratigraphic traversal upward or downward, which makes it much easier when we're looking over here in the vertical panel. Now this vertical panel is showing my local type log, which is the TVD of this well. And then the blue curve is taking the LWD in this dip segment and converting it to TVD based upon this dip of 1.063 degrees. And you see there is no folding back and forth on itself because it looks like we are in just either a stratigraphic traversal up or down. So I just adjust this to match the LWD, and you see it matches here both in the horizontal and the vertical. The nice thing about having the horizontal and the vertical together is that the horizontal gives you an entire look at the wellbore. And it's in measured depth, so measured depth is always increasing, so the predicted curve never folds back on itself. The nice thing about the vertical is it gives you a micro view where it can be very detailed about how I'm looking at tying my dip segment here to the type log. Now I can double click and put in another trial point. So there's another trial dip segment. Come back over here to the vertical panel, adjust it, and see I'm not quite matching right here. Well, that could be from a stratigraphic change or perhaps as a fault. Well, a fault is just a shift in the earth, so I'll hold my shift key down on my keyboard and then slide that up to match that character right there and then adjust the dip. And you can see it's very accurate. If you have the right stratigraphy, you can be very accurate on your fault offset. That's less than 1 foot of offset. Now, at this point, we are moving away from the vertical well, and I'm going to do an offset log that's very close to this well. So the type log, we're going to load from this button. Now, I've steered a number of wells in this project, and they are saved, the steered well is saved to this GSX file. I could use one of those steered wells, but I'm just going to use a well that's close by, and I have a filter to give me the wells close by. And this is the vertical well that I'm going to be using for my type log. And now I have to calibrate this. So I'm going to come over to my vertical panel, and I'm going to turn off the active segment. The active segment is the steered segment. And now I want to match my active type log against my local type log so it matches. Now, by moving my cursor down here, I can see exactly where I'm working. I'm really working in this section of the type log, so that's the one I want to focus on to fit. So going back to the type points tab, I've got a calibration and a normalization tool here. So let's look at the offset. And again, let's focus in maybe down here in this portion of the vertical panel. And let's adjust the offset. And I can do that with the arrow keys on my keyboard very accurately, maybe moving it up something like that, where it matches in this. See, this is where I'm going to be working right through here. And then I can go over here to the shift. Let's zoom out just a little bit, get a little more log in here. And the multiplier will multiply the values of my offset type log, and then shift it back into the range of values for my LWD curve. So something about like that looks like it's pretty good. So go back to my vertical panel, turn back on my active segment, and turn off the local type log. So now I'm just geosteering using the offset log and this local segment right there, active segment. So back to my type points, adjust this, and again, what I'm seeing here matches what I'm seeing here, so that looks pretty good. So maybe put another trial type point right here. Move the options box out of the way. Click in here, pull this down a little bit until it fits about there. Looks pretty good. There we go. Maybe up just slightly. Yeah. Then maybe another trial point right here. And adjust that. Okay, looks pretty good there. And then that last segment, going to adjust it. Something about like that. Now that I've got, 7 or 8 different segments here, I can turn off the selected tie points and get an idea in the vertical panel over here how well it fits, and also in the horizontal panel. Now the nice thing about geosteering inside the model is I can then use my interpreted geosteering active line, like here, the active segment line or target line here, and hang the type logs that I used in each segment. And I'm going to close the smartSTRAT options for now. And this will show me where my geosteering says that the basal atoka should be. Now the geomodel says the basal atoka should be right up here, but my steered well says the basal atoka should be here. Now we're in GVERSE Geomodeling. We have a topology engine working behind the scenes, and I've set up a conformance hierarchy where I'm making the basal atoka control the upper Barnett conformance and controlling the the Barnett maximum flooding surface, basal Barnett, and Ellenberger. So all I have to do is use my picking tools on the basal atoka, tie this to my steered well, and then update my model. And this updates the entire model. So I'm going to click on my Add Surface button, and I'm going to be using Quick Picks. Quick Picks allows me to put a temporary annotation on here. Make sure I'm on the basal atoka. A temporary annotation to show me where I want to tie the model to my type log wells. Once I'm happy with that, I just update by saving the quick picks to the database and to the geomodel. And then everything snaps into conformance. Now fortunately, I'm also tied to GVERSE Geophysics, so I can turn on my dynamically depth converted seismic backdrop and see how well my velocity model is working with my depth converted seismic in this depth cross section. Now the strong positive event over here on the right side is matching the atoka. The atoka is a strong black event, but you notice according to my updated model it no longer ties to the black event here. Well, fortunately, I can push these interwell points back over to GVERSE Geophysics, update my velocity model, and have it update my depth converted seismic backdrop. So I'm going to update the velocity model. Now everything ties. I've updated the geomodel and I've updated the velocity model, so everything ties in time and in depth. So the next thing we're going to do is shift gears. We're going to go over to GVERSE WebSteering. I've got this loaded into my browser. And we're going to set up the connection. Now the nice thing about GVERSE WebSteering is that I can be offline. When you're in smartSTRAT, you have to be either online or remoted in to your computer to do it. You're working inside the model, inside the project, so that's a lot of overhead. It's great to be in there, but if you're offline, if you're on site or in a motel room somewhere, it would be nice to be able to get your information, come in from the field, geosteer it remotely, and then push the results back into the model, back into smartSTRAT to update your geomodel. So here we're going to be looking at this well. This is the well we're going to be steering. I'm going to give it an IP address that I've stored right here, an IP address right here of my server, in this case my computer. Once the connection is made, you select your project home you're using, your project, your AOI, source list, datum, and map coordinates. This is State Plane, Texas North Central. and save it. Now we also have the ability to connect in to WITSML providers of Digidrill, Payson, Petrolink, or any kind of generic WITSML to pull in our data from the field. But we're going to be using local data that could be emailed to you. So once the connection is made, we now go to the dashboard. From the dashboard, we're going to be selecting the well we're going to steer. This one. Get it out of GeoGraphix and put it into the database in a web browser. We're using HTML5, which has its own internal database that we're storing this in. Next, we're going to take the survey. Now, I've got this survey in an Excel file that I simply will drag over and drop, and then I'll parse out the columns to the correct measure depth, inclination, azimuth, and header row and data row. Click OK. Save that to GeoGraphix, then modify the graph options. So this should be 6,000 feet. Tab over, this should be 6,300 feet. Tab over, and 5,000 feet for the X start. Next, we'll get the LWD logging while drilling LES file, and again, we will just drop it in by dragging and dropping, and parse out the curve. In this case, I only have the gamma ray curve, but you could have a secondary curve if you have one here. Save that to GeoGraphix. Next, we can pull in the type log. We can either pull it in from a LES, like a drag and drop like I did before, or I can search locally around the well for the appropriate well. So we'll do that. We'll search within a 2-mile radius. And we'll find the well we need. There it is right there. Select the curve we need, gamma ray, and then the pay zone top. That's going to be the upper Barnett. We'll add that and select that as our type log. Finally, we're going to get surfaces. Now these surfaces came out of GVERSE Geomodeling that I exported as IsoMap layers. So we're going to pull in about 4 different surfaces. We'll start with the Mesa Latoka surface, Upper Barnett surface, Barnett Target surface, and then Ellenberger surface. And then we can color code them appropriately. So for the Ellenberger, it's a dolomite, so we'll give it kind of a dolomite color. Target surface, we're going to do in blue. Upper Barnett, we're going to do in green. And then the Mesa Latoka we'll do in orange. Now we're ready to geosteer. I'm going to zoom down on the vertical panel over here to the area where we're actually going to be working. And we need to calibrate our type log against the segment that we're pulling from the LWD here. And I like to take this down to the landing point and then come over here, slide this up just a little bit because we're going to be working in this section. And we're going to be doing some calibration here also. So let's get the calibration. Grab the log. Tie it about just a little bit more. About like that. So we're calibrated right down in the area where we're going to be using the type log for our geosteering purposes. Okay, we'll save that and create a new segment. And I like dragging this down where I get a little bit of character. So I've got these 2 little peaks right here. Then I'm going to grab the end point. By grabbing the end of the segment here, I'm taking this segment of the LWD, turning it to this purple TVD log, and just like we did in smartSTRAT, we're just going to adjust it to match about like that. And I'm going to turn off the visibility of the other segment, so I'm just working with a particular segment I'm working in right now. Save that. get a new segment, and we're going to move this to about something about like that, and take the endpoint, move it right into here. And by the way, you can see my basal atoka in orange, my upper barnet in the green. There's a basal barnet. And by looking at the depth model that I'm building, it gives me a sanity check that I'm not doing something just outrageous, that it actually fits here, but it also fits the current state of the model when we exported these IsoMap layers. So we'll save this, do a new segment, maybe drag it over here to this little notch. Again, I like looking for character. There's the notch right there, so we'll drag it down there, about like that. Save it, do a new segment, drag it over here to this character. And by the way, to put a fault in, we just grab the start here and move it up and down, moves everything together. So that's how you would put a fault in here. We'll put it right back where it belongs. Something about like that. And we'll move this up here to match this character. Save it, new. There we go. And we'll drag it all the way up here to the end. Maybe pull it down so it matches, oh, about like that. Save that. And over here we can look at our dip segments under the settings for the segments table. These are all our dip segments. We can copy those to the clipboard for a report or sending it in an email. But the beauty here is I may be offline and remote. But once I either get back on my VPN, back into my office, or get on my network, I can export my interpretation here from WebSteering directly back over into my model in my smartSTRAT so I can update my geomodel. So we're going to upload it here to the geosteering demo. That's the interpretation in GVERSE Geomodeling. Then return to GVERSE Geomodeling. And right here, I'll uncheck this one, right here is our exported interpretation from WebSteering. So we'll open it up. I will apply my geosteering template. Make it full screen. Check, and looks pretty good. So this gives you a sanity check by looking at both the WebSteering interpretation and then backload it into smartSTRAT. We can actually look and quality control to make sure everything is tying both in the vertical panel and in the horizontal panel. Looks pretty good. So now let's tie our WebSteering interpretation to the geomodel and update it. So again, we're going to put our type logs on here. And by the way, you can do multiple type logs in WebSteering also. I just didn't do it because I already demonstrated that in smartSTRAT. Again, I can see, according to my interpretation, the basal atoka should be a little bit above the model surface. So let's pick that. And this time, I want you to see the model update. So we're going to pull back over here, and I'm going to turn on the basal atoka surface and zero in here, and maybe move this over to the side. So when I update this, you'll see both the surfaces on the cross section and the geomodel surface update at the same time. So with the upper or the basal barnet selected and my surface points, again I'm using my quick pick mode, and I'm going to tie the basal atoka here, 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 and there. Make sure there are no more points. Save my quick picks to the database and update the whole geomodel. And there you see, everything is now up to date. So if I was to plan a new well, it would plan in the most up-to-date model possible. So thank you for your attention. I hope you enjoy this and I hope it was informative.